Okay, so for homework, you were supposed to be doing every other even. Okay, so like 2, 6, 10, 14, and 18 were your homework. So we're going to go through and do the other evens, okay? That way we just spend some more time going over this topic in case you still don't quite understand it. So starting with number 4, 3 square root of 6 plus 3 square root of 6. When you are asked to add or subtract radicals, the first thing you need to check is to make sure the radicands match. What do I mean by radicand? The number inside the radical. Do these have matching radicands? Yes. So that means your answer is going to be something square root of 6. You just add up the outside numbers. 3 plus 3 is 6. Now remember, if you're not sure if you did it right, you can always check it by typing in the original question, 3 square root of 6 plus 3 square root of 6. And that becomes 14.69693846. Now I'm going to type in my answer, 6 square root of 6, and it'll let me know if I did it right. And I obviously did. Okay? Alright, now number 8. The square root of 18 plus the square root of 18. Did those have matching radicands? So that means we can add them. What does it become when you add them? Right. Where did that 2 come from? Correct. And you're on the right track, but you're not finished. Why do you think I'm not finished? I can factor tree the 18. Right, Fernando? What are the factors of 18?
9 and 9. No, 9.
9 and 2 or 6 and 3 would have worked. 9 breaks down into a 3 times 3, and then 2's prime. Then you would have just circled your pairs, killed 1, kicked 1 out, and then the 2 was being good, so it goes back in the house. But I'm not finished. What do I still have to do? Right, you can't forget about this 2 that was on the outside. It comes down, and it's like, oh, you got kicked out of the house too? Let's join together. 6. And that's the answer. Yes. Just turn around and pay attention. Alright, you were supposed to do 10, so now let's look at 12. Can I erase? Alright, number 12. Do those have matching radicands? No. But we could simplify this one, and then maybe they will match once this one's simplified. What are the factors of 12? Right, either one would work. 6 and 2, 4 and 3. 4 becomes a set of 2's, and then 3's prime. So now we circle our pair of 2's, kill 1, kick 1 out, and then this 3 was not circled, so he was being good, he goes back inside. You cannot forget, though, about this one that had already been kicked out a long time ago. He's going to come down and join the 2 to make negative 6 square root of 3. So negative 3 square root of 12 just became negative 6 square root of 3. Does that make sense? Now when we try to add it to 2 square root of 3, can you? Yes, because now they are both square root of 3's. You just add negative 6 plus 2, which is a negative 4. And that's your final answer. Now remember, like always, if you're not sure, you can type this one in, see what it says on the calculator, type in your answer, make sure it says the same thing, and that'll confirm that you've done it correctly. Alright, number 14 was part of your homework, so let's look at number 16. Can I erase? Okay. Number 16, can those be combined? Yes, and don't all of them have an understood 1 out here? So what's the answer? 3 square root of 2, right. Alright, number 18 was homework, but we are going to go over it because I saw that a lot of people had trouble with it. Now, for the homework, there were 5 problems. I gave you credit. I gave you the stamp if you at least tried 4 out of the 5. But in the future, I know some of you just looked at 18 and was like, I don't know how to do that. But you could have started it. I know that all of you are capable of factoring. Hold on. I know all of you are capable of factoring the 45 into a 9 and a 5, which would then become a 3, a 3, and a 5. You would circle the 3's, kill 1, kick 1 out, the 5 goes back inside. You would then attach the negative down here, and you'd be done with that one. 2 squared is a 6. You can't do anything to because 6 would break down into a 2 and a 3, and there's nothing you can do. So you just have to bring it down. And then you could factor tree 54. What are the factors of 54? 9 and 6, which would become a 3, a 3, a 3, and a 2, right? So circle a set of those 3s, kill one, kick one out, and then how many go back inside? 6. Both of those, and they multiply to make 6. And then the sign, remember to bring it down, minus. You could have at least gotten that far. Okay, we've learned enough for you to have at least gotten that far, and then maybe you would have been confused, like, well, they don't all match, so what do I do? What you do is you combine the ones you can. This one is not like the other two, so it just stays. But 2 squared is 6 minus 3 squared is 6 is negative 1 squared is 6, right? And then that's the answer. So at least try them. Even when you get to them and you feel like you can't do it, get it started. Show some work that you at least tried it, and then just look at it and chicken out. Okay? No, that's the final answer because they can't be combined. And remember, like always, you could check it. You could type in negative square root of 45 plus 2 squared is 6 minus square root of 54. See what it says on the calculator. Then type in this answer and make sure it matches, and it will. Okay, now let's look at number 20. Can I erase this work?
Yes.
Okay, number 20. Can we currently add them as they are? No. Now, I know what some of you will try to do. You'll say, okay, well, those already match, so let's combine those to 2 squared is 24. But, and you can go ahead and combine those, but then you still got to remember you got a square root of 20 and a square root of 54. Now, none of them match, right? So we need to factor tree all 3 of them. What are the factors of 24? Which then becomes a 3, a 2, a 4, and a 4, right? I mean a 2 and a 2. So we have a set of 2's, one gets killed, one gets kicked out, and 3 and 2 go back inside to make 6. And you got to remember there was a 2 up here, so this becomes a 4. Okay, so 2 squared is 24, which was obtained by adding those, became 4 squared is 6. Now we do this one. What are the factors of 20? 5 and 4, which becomes 5, 2, and 2. So circle, kill a 2, kick out a 2, put back in the 5. And then keep in mind the sign was plus, so I'm just going to bring down a plus. And then 54, what are the factors? 9 times 6, which becomes 3 times 3, and then 3 times 2. Circle, kill, kick out. Those 2 go back inside, making a 6. There was a plus, bring it down. Now can you combine anything? Right, those become 7 squared is 6, and then you cannot do anything with that one, so just write it separate. And then if you're not sure, type it in, see what it equals on the calculator, type in the question, make sure it equals the same thing. Okay? Alright, make sure if you didn't do the other evens that were for homework, you get them done by the time we turn in the packet next Monday. Okay, now flip to the next page. With multiplying radicals, they do not have to match. Now, sometimes they will, but they don't have to. All you do is multiply the numbers. What's the square root of 6 times the square root of 6? The square root of 36. And what is the square root of 36? 6. Now let me show you why that works like that. Let's think back to like middle school. If you have x plus 5 equals 10, how would you solve that problem? Subtract 5 on both sides, right? And you are doing that because addition and subtraction are inverse operations. They cancel each other out, correct? So what if you had 5x equals 10? How would you solve that? Divide by 5 on both sides. And we do that because multiplication and division are inverse operations. They cancel each other out. Okay, well what you haven't learned yet is that the square root and squared are inverse operations. They cancel each other out. So the square root of 6 times the square root of 6. Isn't it basically just the square root of 6 squared? Isn't that the same thing? Well, so don't the squared and the square root cancel each other out, leaving just a 6? That's why you ended up like that. Like if you had the square root of 4 times the square root of 4, the answer would just be 4. The square root of 5 times the square root of 5 would just be 5. Okay? Because when you have the same thing, you're basically squaring it, which cancels out the radical, leaving just the number. Okay, but they don't all match, so that you can't all do them that easily. The square root of 20 times the square root of 25. What is 20 times 25? Calculators. 500. But obviously we're not finished because we can go further. We can use what we learned 2 days ago and factor tree it. Okay? So what numbers do you want to start with to multiply to 500?
50 and 60.
You could start there. Or couldn't you have just started with 20 and 25? Those are the most obvious ones that multiply to 500. 50 then comes down to 5 and 10. 10 breaks down to 5 and 2. 5's prime, so it comes down. 10 becomes 5 and 2. And then those are prime. Now remember, if you're ever working these and you're like, man, I'm not sure if I did my factor tree right, can't you just type in your factors at the bottom? 5 times 5 times 2 times 5 times 2. I've typed in a 5, hold on. And then it equals 500. So I know we have the right factors. Okay, now that we know we have the right factors, we're going to circle, kill, and kick out. Even though these 2's are not sat right beside each other, you still circle them. They're still a pair of 2's. So get rid of a 5, kick 1 out. Get rid of a 2, kick 1 out. Okay, since they're both outside, they'll multiply together. And then 5 was the only one not circled, so he goes back inside. Just like always, if you're not sure whether you did it right, type in the question, the square root of 20 times the square root of 25 and it equals 22.36. Now type in your answer, 10 square roots of 5, and you get the same thing. So we know we did it right. Okay, let's look at number 5 together. Okay, right. The square root of 6 times the square root of 12 is the square root of 72, which you could then factor tree. What are the factors you want to use for 72? 6 and 12 would work. 8 and 9 would work. Okay? 6 breaks down into 2 and 3. 12 breaks down into 3 and 4, or 6 and 2. It doesn't matter. And then everything's prime so far except for this 4, which breaks them down to another set of 2's. So how many pairs can I circle? Right, I have a set of 2's and a set of 3's. What's the only thing not circled? So he goes back inside. Get rid of one of each of the pairs. The others get kicked out, making a 6. Okay, you want to try number 7? Unless they're right. Yeah. Okay, so go ahead and try 7 and 9. What you get when you multiply the square root of 10 times the square root of 5. And then once you factor tree that, what'd you get? 5 square roots of 2. Does everybody agree? Okay, number 9, square root of 10 times square root of 8 is the square root of, and what is it simplified to?
4 square roots of 5.
Everybody agrees? You got 8? Okay, let's look at it. Okay, so 80 would factor into 10 times 8. That would become 5 times 2, and 8 would become 4 times 2. 5's prime, 2's prime, 4 breaks down into another set of 2's, and then this 2's prime. So we circle our pairs. We have 2 sets of 2's. So the only thing going back inside is 5. Then this one gets killed, this one gets killed, these 2 get kicked out, making 4 on the outside. Okay, number 11. What's different about number 11? It has a negative. So, you're going to do everything the same. Square root of 5 times square root of 15 is the square root of 75. 5 times 15 is 75. But then isn't this a positive out here? A positive times a negative is a negative. It's just kind of like a -1 sitting there. And this is a positive 1 over here. So now we factor tree the 75. What factors do you want to use? Okay. And then 5 5's prime, so we'll just continue dropping. 15 will become a 5 and a 3, and then we're done because they're all prime. So we circle our pairs, kill one of them, kick one of them out, 3 goes back inside, but you can't forget to bring that negative down, and that's your final answer. Okay, go ahead and try 13 and 15. Continue on, turn the video back on. Square root of 10 times the square root of 20 is the square root of
200.
200. And then when you factor tree that, you get what? Okay. Alright. It should be 10 squares of 2.
Oh, no.
Because look, Marty, think about it like this. If you were to put the 2 on the outside and then you did your check method, 2 times itself is 4. 4 times 10 is 40. We're trying to get to 200. This one works. 10 times itself is 100. 100 times 2 is 200. Okay, number 15. Hey, number 15. Shh, we're almost done. Well, I'm almost done with my part. The first thing you do is you multiply the outside numbers. Negative 4 times 2 is negative 8. Shh. Square root of 15 times square root of 20 is the square root of what?
300.
Now you have to factor tree 300. What numbers multiply to give you 300? Okay, yeah, you can use many possibilities. 15 becomes 5 and 3. 20 becomes 5 and 4. You then have 5, 3, 5, 2, and 2. Okay? So, circle your pair of 2's, and even though they're not side by side, you circle your 5's. So the only thing not circled was that 3, so they get to go back in. Now, out of the circled stuff, you get rid of one of each of them. So get rid of a 5 and a 2. The other 5 and the 2 get kicked out and become a 10 because you multiply them. So then you can't forget that we haven't dealt with this negative 8. It's already outside. So he's like, oh, you got kicked out too? And they join together. Negative 80.
It's like the girlfriend goes, you give me another one.
Go. 5 squared to 2 times 5 squared to 12 equals 25 square roots of 24. Then you have to factor tree the 24 into 8 times 3, or you could have used 2 times 12. That becomes 4 times 2. I got some butterfingers. And then 3.
I need a butterfinger.
And then 2 times 2 times 2 times 3. Everybody with me? All I've done so far is a factor tree of 24. Now I'm going to circle my pairs. I've only got one set. Get rid of the 2, kick out of the 2, put those back inside. When they go inside, they multiply together. But then you can't forget, this much older brother got kicked out a long time ago, and now he joins the 2 to make a 50, whatever, 50 square roots of 6. All right, number 19. Why don't y'all go and try 19? All right, number 19. Maggie, what do you get when you first multiply them? Well, right, 15 square roots of 45. Then from there, we can factor tree the 45. John Michael, what are the factors of 45 you want to use? 15 times 3 is 45. So what? 9 and 5. Or we could have used 15 and 3. 9 becomes 3 times 3. 5's prime. We have a set of 3's. Get rid of 1. Kick the other one out. 5 was being good. But then you can't forget about this older sibling that joins up with a 3. 45 square roots of 5. Now remember, like always, once you're done, you could check it. Couldn't you type that in and make sure you get the same thing? And then you'll know you did it correctly. Alright, your classwork / homework, if it's not finished, is the evens on this side of the page. Tomorrow, yes, all of them. We have a lot of class time left. Tomorrow, we're going to work on the last topic. Thursday and Friday, we're reviewing. Monday and Tuesday is your test. And we'll also be turning in the packet on the test days. Okay?